by some wonderful presenters. And today, we're going to talk about how you can scale and secure your MongoDB-compatible apps using Azure Cosmos DB. So the agenda is pretty simple. First, we're going to talk about building on-prem open source solutions with our native tools. Then we'll pass the mic over to Yugabytes. After that, we're going to talk about how you can migrate and scale to and with Azure Cosmos DB for MongoDB vCore. And lastly, we're going to build a hybrid solution together. So let's get started. Well, actually, before we start, I do want to have a couple questions for you. So I know it's pretty early, but raise your hand if you love data. Yeah? I better see everybody's hands up. It's 9 a.m. And well, actually, raise your hands again if you love theme parks. Fairs? Anyone? Awesome. OK, so do you ever wish you could enjoy both data and fairs all in one place? Maybe, maybe not. But I do want to introduce our new project, actually not, Kuntasaland. So it is the only park that's not only data-driven, but data-themed. I know it's a crazy concept, but I do see some interest. Y'all kept your hands raised. But we're going to have the greatest rides, the greatest attractions, and most importantly, a ton of data. But we are facing a big issue here. How will we store it? So let's specifically talk about visitor data for now. We've got, we use wristbands and the mobile app to track guest information, entry to and from the park, and the wristband data itself. All of these databases are just connected, and you can query through using all of them at the same time. But with all this data, we have a couple of requirements. So first, we want our data to be reliable and available, since there will be a lot of data inputs when people go to rides, their purchases, check-ins, and so much more. We also need schema flexibility in case a guest changes some parts of their profile, which kind of leans us more into going NoSQL. And as we grow, we want to ask things like, what's the average ride duration for guests who visited 3+ zones in the park? Or who is still in the park and has spent over $100? Lastly, let's just say it, we're starting off, we don't have a lot of money, so we want something that's cost effective. So after drawing out these problems, we have something that looks like this. We want a database that can create and store vectors, and as well store original documents. And when a park operator wants to search data, they can either search directly through the database or create embeddings and create queries and just get the information that they need now. So after assessing all of our database options, we found that the best solution was DocumentDB, which I will show you just about now. So what is OSS DocumentDB? It is an open source MongoDB-compatible database engine. It is the very engine that powers Azure Cosmos DB for MongoDB vCore, offering a modern document model on top of distributed Postgres Foundation. So you can think of it as SQL-backed NoSQL, which is really cool. It also supports the MongoDB Wire protocol, so existing drivers and tools like Mongosh, MongoDB Compass, and ORMs just work. And best of all, it is completely open source. But what does that mean? So that means that you can use, modify, and basically do anything you want with a code that works without just starting from scratch. In our keynote, did y'all go to the keynote? It was great. Satya talked a lot about the open agentic web, which is something that struck me a lot because I felt that it connected so much with DocumentDB itself. Because if you want to, for example, build your own apps, your own agents, why not make it backed by a truly open source database that can do just that? But not only can you run indexing, vector search, and geospatial queries on-prem and across clouds for free, but it is truly driven by your needs, the needs of the developer. If you have a question or want to see a new feature, you can basically just ask us on GitHub or Discord, where we have a growing community of over 1.7 stars on GitHub in just over 3 months, which is a pretty big accomplishment for us. Additionally, we're making our use as easy as possible with Docker, and as of this week, our very own DocumentDB extension for VS Code, which I'll show you later. And lastly, and my favorite part, we're joined by our wonderful partners like Ferret and Yugabyte, with many, many more on the way. So now I will show you a demo on how you can get started on your own machine and only using VS Code. So here I have my workspace, and as you'll see, I have some sample data. Oh. There's my workspace, and as you can see, I have some sample data with rides, transactions, but we'll just focus on visitors for now. And if you click on visitors, you'll see that there's entries, guests, and wristbands. And you'll see with entry ID, guest ID, and wristband ID, all of these databases are pretty much connected together, which means that you can, that I could do queries in between different collections. So here I am showing you all of the different databases, but the first thing that I'm going to do is open up Terminal, and I'm going to run a couple queries here. The first one, I'm going to pull an image based on a pre-made container that we have, so you can literally just run this query. And right now, I'm making a couple queries to create the image, which you'll see here. It just says DocumentDB over there, and everything's already preset, pre-made. And just, honestly, one query. I just wanted to make it pretty, so I did 3. But my next command, I will be building the container itself. And as you can see, that's our port number. The name of the database is DocumentDB Contosoland. It is created through DocumentDB. The username is admin. And I just want to keep it simple. So the password is just pass. So after creating it, as you can see, we have, in less than a second really, we have the DocumentDB container fully built and ready to use. So the next thing that you're going to do is travel all the way down. You see that database with the little brackets? That's our very own extension. So it's simple as adding a connection. The connection string is pretty straightforward. It's a preset string with the port number, username, password. And after clicking it, it automatically recognizes the username and password, and you can connect it to the database itself. But if you truly want to get the full advantage of using DocumentDB, you can also establish a local connection through here. Using the connection string, it finds the port number, and because of security, you need to put in your username and password again. But as you can see, you have the local connection without even having to just staying in VS Code. So right now, what I'm doing is creating the visitors database that you saw before, and creating different collections for, sorry, I had to click some stuff out, for entries. And then I'll just go really quickly and create the same for guests. Oh, typo. For guests and wristbands. So we have the collections there, but it isn't connected to our data just yet. So the first thing that we're going to do, oh, yeah, here. It's not connected to our data. But connecting to it is pretty simple. So you right-click on your target collection, and you find the data that you want to import. So after refreshing, you'll see that all of your data is established right there. And just give me a second while I do the same things for guests and wristbands. But you'll see that, for example, if you go to wristbands, you'll see that everything has been successfully imported. And there's different views. So if you don't like table view, perchance, you can see it as a tree, or my favorite, JSON view. But does that sound pretty simple to you? Awesome. So now it's time to run a couple queries. So the first thing that we are going to do is open up a scrapbook. And that's basically our playground to run any Mongo queries that you want. And they can be as simple as, for example, finding a guest profile by email. So after pasting that, you can run the command individually. And through the email amarapatel@example.com, I can see their guest ID, their name, their age, their interests, and their favorite zones, everything that we have stored there. Or you see how if you want to run a more complex query and using multiple database or multiple collections, you can do that too. So here I am running a more, just a harder query. It's aggregating through two different collections, and you can run both commands or any commands at the same time by using the Run All button at the top of your page. So the data was a little bit long, but you can basically find all your query results all in one page. And so who here remembered all of that? No one? No? No. Forgot to say there was a quiz. It's okay. I created a whole demo for you right there. It's literally just click and play, where you can run the same commands on your own device. Also, I've put in some QR codes for our GitHub and Discord, where you can join us and start connecting with our community. And lastly, if you want to check out our extension, you can look at that last QR code right there. Really appreciate it, and I'll give you all a minute. Okay, great. So with DocumentDB, you have a choice on where you can run your workloads, and one of those examples is Yugabyte, one of our wonderful partners. So I'll give the mic to them. Thank you.
Thanks, Benny. So I'll kick off first. Hey, folks, in line with the questioning from Patty, who uses Postgres? Okay, and has anybody heard of the Yugabyte? Okay, the right crowd. So we're going to talk a little bit about Yugabyte. Yugabyte was formed in the cloud back in 2016, so we have the privilege of kind of building it when cloud-native applications were built in. There's a section here talks about what our open source DNA is. I think it skipped back. Oh, there you go. So how many clusters we have deployed, how we are available, our GitHub stars. And I wanted to focus a little bit on the enterprise section here. So that's kind of a small section of our customers. Some of the customers that are not mentioned here would be the top banks in US, which are globally doing business for folks who are doing 401k globally. Paramount Plus is another customer. So if you have seen the Tyson fight that happened, and the fact that another network which was showcasing a similar fight went down when everybody logged in, but Tyson one didn't, that kind of shows you the capacity of Yugabyte. So essentially, what we are doing for our customers is we are solving the mission critical problems for our customers, which is in particular around scalability issues, multi-region issues, and resiliency. So that's kind of the focus that we have. This is the pedigree of the company. The folks who founded the company, they are the folks who built the first database for Facebook Messenger. So Facebook Messenger back in 2007, when they were building the Facebook Messenger, and they wanted a database which would have a commit regardless of where you are in the world, have an active system. These are the folks who built that for Facebook. Same folks who built Oracle, the core engine of Oracle database. And these are the folks who also built Cassandra and named Cassandra as we come to know it today. So that's kind of the pedigree of the company. With that, I'm going to go and invite my colleague over here to talk a little bit about and delve into the technicalities of what Yugabyte DB is. So Hari, I'm going to hand it over to you.
Thank you, Rohan. So what is Yugabyte, right? So we are a distributed PostgreSQL database, 100% open source. And what we offer is built-in resiliency and high availability, and it is scaled horizontally. And so scalability and availability. It runs geo on multiple geos, multi-regions, whichever node, whichever cloud you want. It's fully ACID compliant, so you can expect the same guarantees as Postgres, same isolation levels, and we run on multi-cloud, pretty much anywhere you have, right? Give it a node or a pod, and it's just going to run. And we can run it for you too if you want. What does all of that mean? Like, so just dive in. So like most databases, we have two layers. There's the extensible query layer on top and the storage layer. And the storage layer is like inspired by Spanner. And so we do automatic sharding for you. All the tables, we will figure out how to shard it, how to load balance it, how to distribute across the different nodes. And we do distributed transactions for the transactional capabilities. It uses hybrid logical clocks, so you don't have any hardware requirements. And it's all replicated using Graph. So it's all consistent and replicated. Now, up at the query layer, so it's multi-model. Right? So we have two offerings as of yesterday, which is the fully Postgres compatible SQL offering, and that is built with Postgres. So it's going to run Postgres executables in there. And then there's the Cassandra-like SQL offering. So they're both SQL and NoSQL up there. And this is an actual very old slide. And with DocumentDB now, we have a Mongo compatible API. So it doesn't matter if you like SQL, NoSQL, Mongo, Cassandra, the API is there, and the underlying storage layer for all of them is the same. How does that look for your app? So from an application perspective, if you write a Postgres app that talks and works with Postgres, you just point it to Yugabyte, and now it's just going to run. Right? Underneath, Yugabyte is going to connect your queries to the right node, route the requests to the tablets, do all the cross-node splitting, sharding, all of that stuff. It's all baked in deep into the database layer, so the app doesn't even have to know about it. And it's just going to run. So it's just lift your Postgres app and shift it to Yugabyte and run. But what does it mean for Mongo? Yugabyte's open source, DocumentDB is open source, we are Postgres compatible, so you're like, let's run the extension. So once you put the DocumentDB extension on Yugabyte, you get a scalable Mongo app, right? There's one more element in the picture here. So because we are Postgres, we talk the Postgres protocol, and your app is going to talk Mongo protocol. You need to have a gateway in the middle, which it can be Ferret or the Microsoft own gateway, which acts like a translator. The DocumentDB extension is going to be responsible for the actual API and the data manipulation within Yugabyte. So your app is going to be, a Mongo app is going to be now fully scalable and run on a fully OSS environment. Now, enough boxes and arrows, right? Let's go to a demo. Yeah, we love theme parks, but also here, our demo is going to be a conference, right? So we're going to have a build conference. So I have a 3-node cluster here, and we are using 3 nodes from Azure WestGS 2, one on each zone, so it's going to be resilient to any zone outages. They already have FerretDB installed on those 3 nodes to act as the gateway for this setup. And we have an awesome UI to show the state of the cluster. I have a few collections for our conference, and you can see that this, depending on the size of those collections, the tablets, which are shards, automatically scale up. So the small ones have a few accounts, the sales with 4 million sales has like 6 tablets. And these are, and in addition to all the internal and system tablets, are automatically spread across those 3 nodes. In this setup, I have an even distribution. It's all in one region, so I don't mind which node is the leader of these tablets. To operate on this, I'm just going to use the MongoDB extension for VS Code. It's just like the regular Mongo one. And we give the 3 node connection endpoints. You can use a DNS if you want, but I just want to show you that I am hitting the 3 nodes. I don't care which node I hit, it's going to look the same, it's going to feel the same. And we're going to insert our speakers. I'll insert myself, age, an array of social media accounts, emails, and whatnot. And I'll add Rohan, my friend Rohan here, 48, with his own stuff in there. And then we'll add our friends from Microsoft, like Kaylan, Sidesh, and Patty. And always, once I insert, I always check. I don't know. I always count the rows. So we have 4 rows, and you can see all of those JSON entries in there. Now, to make it a little bit more fancy, I'm just going to insert 200 random speakers. It's just like random numbers. I don't mind which ones. And there you go. So now I can go and count. And I always check my database. I don't know. I don't trust databases maybe. So I'm going to just do some basic aggregations. Just a count based on age, greater than 40, less than 40. Right? And these total should be 204, so 57, 147. There you go. It works. And we can then also do some more complex queries, right? So we have an array in here. So I'm going to look for an element within the array. So I'm going to see who has a MySpace social media account within the array of a document. And there you go. You get back Rohan. You can do projections and everything. You can also run a little bit more fancier queries. So you can run the same pipeline queries like you could with DocumentDB. And in this example, we are going to have some group by, match, project, unwind. This is a simple one, but you can make it as complex as you like. And this, on a traditional relational database, is going to involve cities, joins, multiple tables. But with the document model, it's all in one collection. Everything's in one space, and you can just go query it, right? And there you go. So now let's make it distributed, right? We can see that the sales is actually picking up. So we are at 4 million T-shirts or something. So we are picking up sales. Let's say the cluster's getting hot. Let's scale out, right? And we are at 3 nodes. So I'm going to go in and add a few more nodes. So we'll go from 1 node per zone to 2 nodes a zone. And so that we're going from 3 nodes to 6 nodes. Right? And just hit proceed. And now it's going to go to Azure, provision the VMs, install the software. So that takes a few minutes. I'll just like fast forward this part until the nodes are actually ready and come to Gigabyte. And should be ready almost. There you go, back to real time. You can see the 3 hosts are already there, and the tablets should start moving. Right, there you go. But even before the tablets move, the query layer is running on those nodes, and they are processing queries. So you get the compute as soon as the nodes are available. The storage is just going to move depending on the size. The small tablets move really quickly, and the big ones take a few more extra seconds. Actually, the sales has actually picked up. It's at 6 million right now, and while we're doing it, it actually split from the 6 tablets that we had before to 8 tablets. So all of this is automatic and hidden from the app. The app doesn't know or doesn't care how many tablets there are, how it's getting load balanced. It's just like magic to the app, right? So it's just a Postgres app. It doesn't have to change. And right about now, I know that this is going to go from 8 tablets to 9, because as the sales keep going up, the count is just going to go up. So right now, there you go. So, yeah, so yes, once the sales go up, we add nodes. You can add more nodes. If the requirement goes down, you can remove the nodes. It's going to move those tablets back to this all 3 nodes, and you can scale down on demand. And thanks for watching. That's a demo. And there you go. And hand the mic over to Patty.
Awesome. So remember Contosland? It wasn't too long ago. I'm just going to repeat it. It's a great idea, but that's probably because it's mine. But let's just say that after y'all left not Contosland, but after you left this room, y'all went immediately to Contosland. Y'all loved it, told your friends. It's starting growing. Fast forward a couple months later, it's growing, and it grew so much that it was too big, or the data that we stored is too big for our in-house servers. We couldn't keep processing anytime. We needed more capacity either. Also, we had to be a lot more cautious about our downtime, and our hacky DIY recovery tactics just weren't covering it anymore. Lastly, as our park grew, so did our threat surface, and we needed security that scales with us. So now that we know why Contosland is moving to a managed service, the next question is, how do we actually get there? Well, there are 2 main paths to migrate your MongoDB workloads into Azure Cosmos DB for MongoDB, vCore offline migration and online migration. So offline migration is ideal for development testing or smaller systems where a bit of downtime is just fine. It works by taking a snapshot of your source data and copying it over, but you will need to pause your app when that happens. Think of it like moving houses while everyone else is on vacation. Online migration is designed for production systems that can't afford to go offline. It starts by copying the full data set, then uses change streams or oplog telling to replicate the new writes into near real time. You get to keep your app running and make changes, but when the 2 systems are fully synced, you can perform a final cutover. So For Contosoland specifically, we are operating constantly, and we handle guest activities in real time. So we really can't afford to have that downtime. So I think an online migration could be the best for us. So now let's talk about the actual tools Contosoland or any team in that matter can use to perform an offline migration to Azure Cosmos DB for MongoDB vCore. So for a small workload, you just need to move a subset of data, which the simplest tools to do that are Mongo exports and Mongo imports. You export your data into JSON or CSV, and then just import it directly into your Cosmos DB instance. This method works great for selective collection migration, test data seeding, or just when you want the data to be human readable and easy to edit. For larger or full database migrations, MongoDump and Mongo Restore are your go-to tools. They use the VSON format, which is compact, lossless, and better suited for preserving the full MongoDB structure and types. It's also the preferred approach if you want to do a lift and shift into the database quickly and cleanly, especially when you don't need to transport the data in any way. Beyond core MongoDB tools, Azure offers snapshot-based services that can help move or enrich your data. So there's Azure Web Apps or Azure Databricks, for example, that can automate exports, run scheduled jobs, or apply transformations before pushing to Azure. These are specifically useful if you're migrating data as part of a larger app modernization or analytics pipeline. So let's shift to online migration path. The process starts with a bulk copy of your existing data. This creates the initial baseline in the target system. So in this case, Azure Cosmos DB for MongoDB vCore. Next, the migration tool kicks in and begins tracking all new changes in your source database. That includes inserts, updates, and deletes, which you will see later. This is powered by features by change streams or the MongoDB oplog, depending on your source environment. From there, these changes are continuously and automatically applied to the target database. This ensures that the source and the target remain in sync all the way up to your scheduled cutover time. And the good news is you don't have to build this pipeline from scratch. Azure provides tooling that you can use today. So there's Azure Web Apps for orchestrating and running lifetime services, Azure Databricks for real-time transformation during replication, and Azure Data Studio for monitoring or managing your migration workflow. So let's put all that into action. So our migration could look a little bit more like this. So the first thing that you're going to do is click on a new job. There we go. You're going to name your job. So in this case, I'm going to call it Job 1. And as you can see below, we're using MongoDump and Mongo Restore. We're going to paste our source connection string into here, and then our target connection string for the vCore account that you created. Next, you're going to give it a list of the collections you want to migrate. So we'll do that just here. And this is where you can choose to migrate either online or offline. So in our case, we want to migrate online, so we're just going to click the checkbox right there. And if you select online, the changes in the source during the migration will automatically get synced to the target. As you will see right now, you click OK. And the web app will give you a status of the collections getting migrated and show you in real time. Let's just wait a bit. OK, one more. And great. So now we see that the download and upload for both collections is complete. And the cutover button is right there. But let's say that we want to make a last-minute change to the databases just when we're migrating. We can make that change as we go. And as you can see, the time since last change will change from NA to There we go. So as soon as you make a change, you can see that the change was detected and has been applied onto the cloud itself. And once you're sure that all of the changes are there on source, has been synced on target, you can just click the cut over button whenever you want, and congrats, you just finished migrating your data. So that was pretty easy, right? So just remember, once you click the cut over button, the sync will be broken, and there's no going back to the original database that you just migrated, but good news, you have all that in the cloud. So at this point, you can change your connection string in your application to start pointing to your MongoDB vCore account. So great. Now that we've seen how Contosolink can migrate to the cloud, let's look at what we really are migrating into. So Azure Cosmos DB for MongoDB vCore is a MongoDB-compatible database designed for scalability, performance, and flexibility. So first, you get instant auto-scale. There's no need to guess capacity. Cosmos just adjusts your load in real time. There's a free tier with up to 32 gigabytes of storage. No credit card needed, which is perfect for dev and testing environments. And with geospanning clusters, you can place your data closer to users across regions or even continents with just a few clicks. Cosmos DB is vendor agnostic, so you can connect from anywhere, multi-cloud included. It integrates easily with Terraform for IAC, and you can stream data directly into Power BI for real-time dashboards. Storage, scale up to 32 TIB per shard, giving you headroom for big data-intensive applications. Additionally, Cosmos DB has native Azure integrations from security and networking to monitoring and billing. It supports both vertical and horizontal scaling, which I'll show you later, but it does that all without any downtime. And best of all, it is fully managed by Microsoft's engineers with a full stack SLA. That means you're covered from disk to driver. So what makes Azure Cosmos DB for MongoDB vCore the best way to run Mongo today? Let's break it down into 3 simple pillars: cheaper, faster, and better. So first, it is simply more cost-effective. So cluster tiers are about 20% cheaper across the board. You can scale and compute storage independently. There's also features like 35-day point-in-time restore, which is included in the free tier. And plus, there's no required support contract, which is often a hidden cost for other providers. Lastly, if you're running non-critical workloads, the non-HA option may save you up to 50% on your total cost. Next, it is faster. So Cosmos DB offers instant auto-scale across 2.5x range, so you're never stuck with over-provisioning to peak traffic. It delivers 10 times better performance on vector search workloads, which is huge for AI use cases. Lookup performances, often a pain point for any developer, is up to 90% faster compared to other services. And we benchmarked all of this, and it's not just marketing. Feel free to scan the QR code to see our latest benchmark. But finally, it is just better overall. You get a richer version with DiskNN, including filtered and hybrid queries. Cosmos DB is fully integrated with Azure AI's ecosystem, making it easy to plug into services like OpenAI, Synapse, and more. Our SLA covers the entire stack, not just the infrastructure, which means that you have a real guarantee for mission-critical workloads. And lastly, with native Entra ID integration, security and access management are built in from day one. Let me click. Sorry, let me click the slide itself then. Awesome. So one of the biggest advantages of Azure Cosmos DB for MongoDB Core is how seamlessly it scales across 3 critical dimensions: vertical, horizontal, and storage scaling. So first, there is vertical scaling. This is more of the traditional model where we increase vCores or RAM during our existing nodes. Here, the system distributes data across multiple nodes automatically, so you can scale out for massive throughput and handle larger databases without bottlenecks. So this is ideal for high-interest scenarios like Contentland's guest tracking system or any IoT real-time analytics use cases. And sorry, that was horizontal scaling. Ignore that. So that was applicable to horizontal scaling, where Azure Cosmos DB for MongoDB Core really shines. And that's where the system distributes data across multiple nodes. And that's ideal for Contentland. But lastly, storage scaling lets you increase your disk size independently from compute. That means you can grow your data footprint without having to upscale your CPU or memory, keeping your cost efficient and aligned with actual storage and usage. So let's go one level deeper into scaling, because one of the standout features of Azure Cosmos DB for MongoDB Core is its instant auto-scale capability. So why does this matter? First, instant scale means your database automatically adjusts to traffic spikes. No downtime, no manual turning. It is budget-friendly too. You're not paying for idle capacity, just what you actually use. And most importantly, it eliminates over-provisioning, a common issue where you can stuck overpaying just to avoid risk. And this is a big win for both engineering teams and finance teams. So do we have any finance teams here? No? OK, just tell them later. So how does this work in practice? So first, you can enable auto-scale at any point with 0 downtime. Cosmos DB specifically delivers industry-leading scale-up and scale-down speed, unlike no other services that may take even hours to react. Pricing is designed with customers in mind specifically. So you would be billed based on a usage threshold with a minimum and maximum price bounds. So you get predictable billing without compromising any flexibility. And lastly, it also helps people select the right tier. So that means that you can avoid the guesswork that comes between choosing M30, M40, M50. So you can kind of evade that over or undersizing. And as vector workloads become more common across AI-driven apps, from recommendations to retrieval-augmented generation, or RAG, Azure Cosmos DB for MongoDB Core is stepping up as one of the most prominent and feature-rich options on the market. So that all starts with performance. So Azure Cosmos DB for MongoDB Core delivers 10x higher RPS, that's requests per second, than other MongoDB service running vector search. It also offers significantly lower latency, which is crucial when you're powering real-time inference or semantic search in production. But it's not just about speed. It's also about capacity. We support DiskANN, a high-precision vector search algorithm that outperforms basic ANN methods. There's automatic embedding generation. You also get hybrid search, and but most importantly, there's something that only Cosmos supports: index intersection. So what does this mean? That means that you can run rich queries like, for example, find houses within 4 miles of this location that have AC and are similar to others that I've liked. That's a pretty big question, and that's a pretty big query, but that's something that that MongoDB Core, or yeah, Azure Cosmos DB for MongoDB Core can run. So that kind of query spans vector, geo, and traditional indexes without hand-stitching logic on the app side. So there's a couple more things that stand out. So first, you can scale to millions of embeddings with high accuracy and speed. Cosmos DB also integrates seamlessly with AI services like Azure OpenAI, Cognitive Search, and more. And lastly, it supports up to 16,000 vector dimensions using product quantization, which is ideal for complex or multi-model models. So, yeah. But now, with such a great managed option and with such a great park like Intassaland, we have no issue growing. In fact, we've grown so much that we're starting to go global. Can you believe it? And in fact, we're starting with Europe. So new places means that there's new data requirements. And I'll hand it over to Sudesh to tell you more about what that means. Yeah.
Great. Hey, I'm Sudesh. I'm the engineering manager on Cosmos DB and DocumentDB. So we'll talk about hybrid deployments in this slide, starting with Contosoland, right? So as Patty said, Contosoland is growing. It's going global. We are going into the European Union and European countries. As we go, we started to learn about new requirements there, starting with the very new DORA requirement and DORA compliance that's coming out in EU, right? It became effective earlier this year in 2025. And what this basically means is for mission critical workloads, right? For finance companies, for tech companies, you need to have a resiliency plan. You need to have a documented, proven, tested resiliency plan that actually works across outages, major outages, right? So one of the things that it really encourages is to avoid taking dependencies on similar infrastructure, both for your primary region and for your data recovery region there, right? So it's not that you're using like the same data center to host both or the same set of like networking scenarios. So there is a single point of failure that avoids you, that kind of takes both these clusters down there, right? So there are multiple ways to do this of how do you do kind of data resiliency across different architectures there. And we'll list down a few just so that we can see which one fits best for us, right? So one thing would be to actually have your application deployed across 2 cloud platforms, right? So you can have business continuity by having 2 different service providers. They have different databases out there, and just having like an OSS-centric architecture that allows you to kind of build and connect across different cloud providers there. Second architecture is you could do an on-prem solution, right? You could have your primary region in one of your like favorite cloud provider, your favorite service providers there, and then from there you can have your DR regions in and just an on-premise infrastructure that you own. It's a lot of setup. It's a lot of infrastructure upfront cost to make sure that it works out there. But for some very specific scenarios, that's something that works there, right? And then lastly, you could actually also go into like both on-prem or primary and on-prem, and then your distributed databases or DR regions on a cloud provider, right? For latencies, for making sure that you have the best control over your primary side, you can start with that on-prem. So let's see which one of this works for us for Contosoland there, right? So this is the architecture that we have chosen for Contosoland as it goes into a multi-cloud or a multi-region infrastructure there. So we will start off with our primary region as managed. We want to be lean. We don't want to set up a lot of big IT staff to manage our infrastructure at steady state. So we choose one of the SaaS providers or the PaaS providers there. Here I am using Azure and Postgres for my primary region. Postgres is installed in Azure Kubernetes Service. It's running the DocumentDB extension to power my Mongo application. And as a DR region, I am also planning to use an on-premise site. I have the infrastructure there. So I'm installing Kubernetes on-premise and running DocumentDB there. Right? This is possible this week as we release the Kubernetes operator for DocumentDB that allows you to actually install, manage, and make GeoDR possible anywhere or any provider that supports Kubernetes out there. So that's kind of going to be my setup, right? So I'm going to have my primary region in Azure running on Postgres. I'm going to have my DR region running on-prem, another service provider using Kubernetes. And I have set up a one-way replication for now between my primary database and my DR region. That's super critical for DR. You want your data to be replicated as soon as it changes in your primary region into your secondary region there. So that's my infrastructure setup. Let's talk about app setup next, right? Which is the slides that you see, the charts that you see below. So I'm writing using Mongo. I'm using Mongo application there. It's using DocumentDB under the hood on Postgres, right? So I write to my primary region. So all of my writes, reads, aggregation queries are run against the primary region there using the primary connection string. And now that I have a DR region, I also want to load balance. I want to make sure I can shift some of my workload over to my DR region because, hey, I have the capacity. Why not use for it? Why only keep it for DR there? So this way, in this application mode, I'm using my writes primarily go to my primary, the reads and analytics and ad hoc queries go to secondary. They're using the DR side. Capacity is well utilized across. I'm not paying anywhere in the system while I get the capabilities of data recovery here, right? So with this setup, I want to walk over a quick demo that we kind of do around how to set this up yourself using all OSS tools and how you can kind of go and manage your infrastructure there. So I will start this. It's going to be a VS Code-based extension there. So in this model, we want to kind of give a quick overview, right, of the upcoming features in our Kubernetes operator, right? So what you see here is, it's a lot to pack, but we'll slowly go through this. And I think I'm going to pause it when I want to. Okay, so what you see here is the Kubernetes YAML file, and we are using, let me start and pause this one here. Oh, sorry.
Let
me go back. Okay, can you pause?
Yeah, I'll pause it.
Thank you. Okay, let's start. This one, perfect. Thank you so much. Yes. So this is what our Kubernetes operator is, and you can see that we are using Azure Cosmos. You're using Azure Kubernetes Service and Kubernetes Fleet Manager. So Fleet Manager is, or Kubernetes Fleet is a logical construct. It's a collection of clusters that allow you to manage, deploy, and scale them as one unit there, right? So here you can see on the left-hand side, we have our YAML file that describes the clusters. And here we are going to, we give the document DB syntax. We are creating 2 clusters, one on Azure and one on a local Kubernetes cluster out there in a way, right? Lastly, it will show you about the settings that we want to use for GeoDR, where one of the regions is primary, which is our Azure, and then our secondary region is the Kubernetes, which is our DR region. It is set to deploy all clusters, and then after that, it is also set up to replicate. So let's start creating our clusters. We created our operator right now. Now we are going to create our first cluster here, which is our Azure cluster in a way. So I copy this command, just simple one command using kubectl, created a cluster right there. Going to create a secondary cluster. You can see quick and easy. We have 2 clusters now, both running in Azure. There. Now let's go and get our IP addresses, right? Let's try and verify that is it actually up? Am I able to connect with Mongo, right? So I'm going to use Mongo SH here to just connect to these clusters, make sure that the connectivity is good, and yep, I'm able to connect to my primary cluster. I'm able to connect to my secondary clusters. All good there. Now, before running my app, I want to set up my observability platform, right? Which is, hey, how do I measure my log? How do I get my logs? How do I measure my metrics out there? So for that, we are going to use Kubernetes. We are going to use Grafana as our core observability platform, and that's what the next step does here. Is it just sets up like a Grafana pod in Kubernetes that just ingests metrics from my application there. And we'll look at all of these metrics at the end of the demo, right? Just to see how it worked, how it scaled beyond here. So awesome, I'm there, I'm up, all of my observability is running. Before I switch into the demo, I want to go back and look at DocumentDB VS Code extension that we just released there, right? So let's set it up in DocumentDB as well. We'll use it to monitor our application and to kind of see all the records, right? So here, DocumentDB is truly open source, and it's actually extendable, right? So here we have different service providers. We are going to go and use our Kubernetes service provider to just find our Kubernetes DocumentDB clusters that we just created. And we found 2 of them, the ones that we created. So let's go and connect to them here, right? So a few clicks, it's going to ask you username, password that you have already configured, and you'll see that you get the clusters out here in DocumentDB there. So now I want to start my application. I go in, I have a sample Python app, just generates a bunch of workload out there, just to showcase our DR capabilities here, right? So as you see, the app is running, it's inserting some documents into the system there. While it's running, let's go back to our DocumentDB VS Code extension and see how we can kind of monitor the data. What is there? What databases did it create? What files did it ingest there? So our familiar table view, you can kind of see all the files that the apps are being ingesting in real time, can go through multiple pages. And since we set up DR, these data is being replicated to my secondary cluster as well. And that's what this shows. So we connected to both our primary and secondary. We made sure that all of the data is there real time as ingestion is happening. Very soon, this will stop. We are ingesting just 100 documents over there. So it should just finish putting in all, like ingesting the core of the data that I have. And then I want to go back to the VS Code extension, DocumentDB, and verify, right, do I have all the data that I need to start my application here, right? So, yep, I have all 100 docs. I have a single page. I go to the next page. I should see no data because I ingested just 100 documents here, which is perfect. So the stage is set. We want to go and test our DR, right? But before that, right, as any good developer, I want to see really, is it set up correctly, right? Like, am I able to, as my DR region, actually a read-only region, is it allowing writes or not, right? I want to verify, I don't trust the system. So I run my same application against my DR region. Let's try and see if I can insert data into there. And nope, it cannot. Perfect setup, right? It fails with an insertion error. It says you are no longer primary because you are replicating from someone, which is what I want. I want that region only to read. I don't want it to be written yet, there, right? So with that, let's now start our real application. So our real application goes in with, it takes two connection strings. It takes both to the primary region and the DR region. It sets up in a GeoDR configuration in a way that if the primary goes down, it will go and talk to GeoDR. And that's what we did. We just started off the application. It's running. It's inserting a few documents. Now let's inject a fault, right? For this demo, fault is very simple. I just go in and I delete my primary cluster. Like, imagine it was a networking outage somewhere. And we basically lost all connectivity to the primary out there. And this is slowly going to take effect there. After that, I want to run another command to say that, hey, look, now I have detected there is an outage. Let me go and promote my DR region or my DR cluster as the new primary so that my app can still continue working because I kind of have already set it up. That's what the second command does. It tells you that you need to basically go in and have your replica cluster as the new primary so it can still take writes. It can take writes and keep serving the reads that it was already doing there. So with now you can start seeing failures here. Yep, we saw the first failure. Document 43 failed because we weren't able to ingest into the system out there. And then now the app is waiting for the failover to take, for the DR regions to take up. So here we are trying to connect some initial hiccups in connections, expected connections as data moves in, and soon you'll see that the DR region is starting to inject, right? Perfect here. So this is what shows like a real life DR scenario where you moved your workload from a primary cluster to a secondary cluster without changing your application, without needing to even stop it there, right? By configuring it correctly, and using both these regions, we were able to just keep our app running without any DevOps need and just moving data over there, over to our DR cluster. And I think that's kind of the power of OSS DocumentDB. All of this is possible in any service provider that you support today, and it should just work with the operators that we have. Lastly, I'm going to quickly go over the Grafana dashboards that I created to see how did we scale, how did we perform. You can see that the workload was scaling as I was ingesting. We injected a fault. At that time, our primary request died down slowly as the nodes went out, and then our secondary started taking up the requests, and it started taking up the workload more and more here, right? All this time, our code was available, our application was available, our customers were able to use Contosa LAN, we were able to check in without any disruption, without any long lines at our park. So that's the power of Azure Cosmos DB for MongoDB vCore and the OSS DocumentDB infrastructure that we are releasing at Build. We hope you like it. We hope you continue, you use it, give us great feedback. We are building our community, like Patty said, on GitHub, on Discord. So with that, we come to the Q&A section. I'll invite my friends from Yugabyte over as well. There, we have a booth here down there. If you have any questions, we'll open up a question and answer here. But if you have any questions, you want to connect with us outside, please come and visit our booth. I'll be there. Some of us will definitely be there. We have resources here. We have our DocumentDB core repo. We have VS Code extension that we just released. The third link is super exciting. It just announces a bunch of features that we announced at different stages at build. So you can look at everything new that happens in Cosmos DB and MongoDB vCore. Lastly, we have our friends at Yugabyte, and you can use service providers over there. So I think, yep, we'll open up the podium for any question and answers. Please use the mic. If you have any questions, we'll be happy to answer here. Any questions if you have? Yeah, please.
Yeah.
Can you?
Feel free to join us on the mic.
Yeah. Oh, you can ask. I mean, we can repeat the question. Yes, so we use DocumentDB underneath this, right? But it is you can configure with Kubernetes where you want your storage volumes to be. It could be local, it could be a mounted, right? It could be like Azure Disk, it could be S3 instances. So you have that flexibility there to kind of choose how you mount your storage. So that's something new that we released, yes. So DocumentDB, we released a DocumentDB operator at build, right? Like, so the second link, actually, if you go to the third link, it'll take you to the GitHub of our Kubernetes operator for DocumentDB there, which kind of hides all of this from you, right? Like, it gives you a simpler API. You can define an interface and says that I want 3 nodes. This is the disk. This is the amount of core that we want. And because it's a database, managing is tough, right? Like, we have to look at availability, liveness checks, and all of that is encapsulated behind the operator from the view. Yeah. So you don't have to worry about that, right? And that's something that's there in code, and it's open source. So if you are curious, we welcome you to kind of go look at our GitHub repo, and it should have just exactly how we orchestrate the starting and HA of the database on Kubernetes. There. Thank you. Any questions? Yeah, please.
We are using Azure Government, we are on Government, and the Mongo vCore is not available on Government yet. So I wonder, you say DocumentDB, is that vCore is based on DocumentDB?
Yes.
What about the DocumentDB RU? Is that different? Because on Government, the only option that we have is to use MongoDB.
Are you? Yeah. So let me repeat that question. I think the question with few questions here. Right? One of them is MongoDB vCore, which is the Azure service, is not available in government clouds. There we only have the RU model available here. That's one, and that's right. So MongoDB vCore. So currently in Azure government, you only have Azure Cosmos DB for MongoDB RU model, but vCore is coming soon. vCore is a brand new service that we released 2 years ago. Actually, 1 year ago, in a way, right? So this is our year 2 for the service in GA, in a way, and we are adding more regions. We will be soon available in all public clouds, and then the next step is sovereign and government cloud. So yes, in this year or soon after that, we should be there in RU cloud, in the government clouds as well. But with DocumentDB and with all of the operators in the gateway that you have, it kind of sets you up to just try out vCore in your government cloud while the actual PaaS service lands there pretty soon as well, in a way. And yes, and DocumentDB, given it's open source, it should be available. AKS or Kubernetes services available in government clouds. So you can use our deployment scripts to be able to run your own DocumentDB cluster for now, while we come to Azure government pretty soon.
Yeah. And then to answer your second question, is there a DocumentDB for Cosmos for Mongo RU? So DocumentDB is only available right now. It's only related to vCore as it's the engine powering it. So as of now, I don't think RU has an open source version.
Yeah. So RU is not open source. It's something that's proprietary. That's Cosmos DB core engine that we power. vCore is built on top of Postgres, and it was developed to be kind of OSS friendly. But the tool set that we developed, like the VS Code extension for DocumentDB, you use it with any Mongo compatible database. It works for RU, it works for vCore, it'll work for Yugabyte MongoDB as well there. And that's kind of our intent. Our tool set are going to support any Mongo compatible database, but the actual engine itself that's open source is just the DocumentDB for MongoDB vCore.
Yeah.
There. Thank you.
All right, I think we're cutting a little bit close to time, but if you have any more questions, all of us will be staying outside the room, and also feel free to visit our Cosmos DB booth, booth 810. It is right close to the GitHub community section on the other side of this big room. So we look forward to seeing you all and answering your questions. Thank you so much.
Thank you so much.